Okay, let's review for test one. The best thing to do is go through all your homework that we've done so far. You can do any of that in practice mode. Make sure you know how to do all the problems. I've got practice test one here that you can do as many times as you want. And the way this is set up, on every question, you can hit get a similar question, and there might be different versions of it. So my suggestion is even if you know how to do a problem, like, oh, I know how to do this one. This doesn't count for a grade. Just make up something so that you could submit it and hit get a similar question and see if you get a completely different kind of problem. Every question that's actually in the exam lives in this practice test somewhere. So if you do this enough times, you'll be able to see every test question before the test. Because of that, this cannot be open at the same time as the actual test. This will close before the test opens. Okay, so some questions that might be good. Yeah, like this is a good one. I would know how to do that. This is a good one. I would make sure I know how to do that. This was a homework question. That's just a conceptual question. It's not bad. I would definitely know how to do this. Let's see if there are different versions. I don't remember. Yeah, so there are a couple different versions of that one. Definitely know how to do these when you've got two particles and you want to calculate the force between them. We're just using Coulomb's law here. You're going to have a bunch of Coulomb's law type problems. I just have to answer something so I can say, get a similar question. Hey, look, now it's a different version of the question. And again, I can just keep doing that. Answer anything I want. And look, it's a different version of the question. I like these problems a lot. So we're given the force between two particles at a certain distance. And the question is, what happens if we change that distance? Remember, Coulomb's law says the force is equal to K, Q1, Q2 over the distance squared. So if the distance gets bigger, the force gets smaller. And it goes like 1 over distance squared. So if I go 3 times bigger, the force will get 9 times smaller. So this new force will be 1/9 of the original. And I could probably just type zero point 0.4 divided by 9. Now he wants me to actually do it. So you would type out zero point 0.4 divided by 9, which is that. And then, of course, units is newtons. So make sure you know how to do problems like that. Another just Newton's or Coulomb's law problem. We're going to have a bunch of those. This was a homework problem. Make sure you know how to do that. This one's actually, students make this a lot harder than it needs to be. So we want to find the total charge. Well, we're told that this is a weird question. We're told the charge per area. So if I were to multiply this by the total area, the units would cancel out and I would just get electrons. So what I need to do is calculate the area of the sphere, multiply it by this number, and that'll give me the number of electrons. But this is asking for how much charge. So then I would need to multiply that by the charge per electron that's in the formula sheet. This question, make sure you know how to do this. It's that superposition of electric forces problem. Like we had that group assignment on it. This was also a homework problem. And in the homework, there's a video attached. If you don't know how to do this problem, go back to the chapter 5 homework, do it in practice mode, and watch I think there might be two videos attached to it. There are two problems that were kind of like this, and I 100% guarantee they're on your exam. Make sure you know how to do them. Make sure you know how to write them up properly. Again, go back to the homework to watch the videos about those. This is a good conceptual question. So here we're changing both the magnitude of the charges and the distance. So we'd have to write everything down. The distance is going to have more of an effect than just changing a charge. But in this case, we're changing both charges. Because we're changing both charges, I get 8 and 8 Q1, 8Q1, 8Q2 on top. That's a 64 on top. On the bottom, I get an 8D squared, so 64D squared on the bottom. 64 over 64 cancels out. We just get 1. Like yeah, this question's okay. I wouldn't spend too much time thinking about that. I'm just trying to point out the ones you definitely want to know how to do. You should know how to do this. Remember, F equals ma. So if you calculate a force, divide by the mass, you'll get acceleration. Well, how do we calculate the force? The force is Q, the charge, times the electric field. So we're going to use F equals QE and F equals MA. Put those together and solve for A. You will have some conceptual type questions like this, where the question is which way is a negative charge going to move in this electric field, that kind of thing. Like here's a different version with a positive charge. Those are good questions. What does the electric field look like from a charge and so forth? I would definitely make sure I know the answer to that. I would know the answer to that. I would know the answer to that. Those are all good questions. This is a homework question. Make sure you know how to do this. I think there's a video attached. Let me open up in a second window. Okay, I'm going into the chapter 6, Gauss's law homework. Yeah, there's a written example. There are the two different versions of this problem. One where you have an electric field passing through, like this one, and one where we have a charge placed in the center. Either one of these could show up on your actual exam. Look, both of these have a video and a written example that go along with them. Make sure you know how to do both of these problems. I like those problems. Look, that was a pretty big hint there. And let's see if we can find a different version of this problem. Hey, look, it's the other one. That was like both of these. Okay, so good rule of thumb, go through all the homework, make sure you know how to do all the homework problems. Let's see if there are other good ones here in Gauss's law. Yeah, these are all good problems. And I just want to see if we can get different versions of this. Yes, look at that. There are different versions. I wish each problem told you how many versions of it were available. Maybe if I have time, I will. Maybe by the time you get here, I will have edited this so that every question will tell you how many different versions of that question there are. That'll take me a couple hours, but I'll try to do that. Okay. So just study, just practice a lot of these. Take your time on the exam. You've got plenty of time. I think that should do.